Good day, YouTube. It's the 3rd of October 2020, and today we're going to talk a little bit about solar panels. This is what I call my solar shed, and that is a 100-watt solar panel. It would have been very easy for me to hook up power to the shed, but I've always had something that run on solar, and I thought this would be a great opportunity to do that. 100-watt solar panels shouldn't cost more than $100. We're at this $1 a watt pricing level right now. So if you're paying anything more than $1 a watt for a solar panel, you're not shopping enough. We'll talk a little bit more about solar panels, but let me show you quickly inside the setup. This is a very simple, very easy setup, very economical. So this is inside the solar shed. I made my own lights in here. I bought 1156 12-volt LED bulbs, and then I bought these little surface-mounted sockets and put them on single gang blank ivory plates, or white, whatever color there, and made my own lights. I'd like to utilize the attic space more than this. Was not much attic space, but I'm finding stuff to store up there. So, and I didn't want them low, so I'm just kind of a compromise, but I am losing some light due to the stuff that I'm putting up in the attic storage. Put one little light over the bench there, and this is the charge controller. I believe it's 30 amp rated charge controller. You can see we're at 13.5 volts, which means we're topped out. And then there's a fuse block, regular automotive fuses. So basically the solar panel connects on the left side, positive, negative. Battery connects on the right side, positive, negative. The other two screws there are so you can connect a load to it. Say you have a specific load you want, you can connect it there. And then buried underneath the bench is a single Group 27 RV battery. Okay, just single battery. If I use the shop more, it might require a second battery for storage, because on the weekends the battery's fully charged. On the weekends 2 batteries could be fully charged, but I don't have any problem with battery life. I have a 12-volt TV. I have a 12-volt AM/FM CD player out of a motorhome or something. So I have everything I need out here, and I have a fairly large inverter mounted right there. It's just something I picked up at a yard sale to run 120 volt items. So it works fine for me. It might be something you'd consider doing for like a she shed, an off-grid cabin, an RV, or a little shop or a little shed or something. So let me show you some basics on how to put together your own little solar system here. Alright, I've mocked up a little setup just to give you an overview of the basic components of a small solar system. So say you purchase a solar panel, and now what? What is it going to take to get everything working? And what if you have a couple of them? What if they're different? So we're dealing with a 12-volt system. So you're going to get solar panels for a 12-volt system that have a voltage rating of, like 18, 20, 22 volts, something like that. And then you're going to purchase a regulator. The regulator is going to regulate the voltage and current output of your solar panel or panels. So believe it or not, both of these panels are rated for 5 watts apiece. I've had this panel for some time. It's a better quality panel. This one is a Harbor Freight. Harbor Freight, you can see, is 2 to 3 times the size for the same output. It's not as efficient. Alright, they're a much cheaper panel. I picked this up brand new in a box at a yard sale for $5 with all the hardware. I wouldn't mount that on any vehicle, building, boat, RV, whatever. Basically, it's a cheap panel, and I wouldn't go through all the trouble to mount such a cheap panel on something I cared about. Right now they're just kind of sitting out here. This in here I've had for some time. I was going to put it on my enclosed trailer just to keep trickle charge on the battery inside, but I really ended up never installing it, and I don't have the trailer anymore. So for this demonstration, both these panels are tied together in parallel, okay? They are right here. Both of the positives are tied to one wire that goes to the regulator. Both the negatives, the blacks, are tied together, goes to the solar controller, if you will. Okay, so those panels are now working together. They are rated at 5 watts a piece. They are right now pointing straight up. It's it's a little after noon, so it's appropriate to have them straight up. You could check in your geographic area what the correct angle they should be to get the most amount of sun for a day. But remember, you'll likely never achieve 100% of that solar panel's rating for more than, say, an hour in any day, and that's if you have them pointed in the exact direction that they should be. Unless you have some sort of fancy sun tracker alignment system, which is motorized and would constantly change the angle of these things, which is cost prohibitive for most people, you'll never get to what they're rated for, okay? So if these were 10 watts together at 12 volts, I don't have a calculator with me, but that's going to be around, 0.8 of an amp, or 0.8 amps, okay? I have both the charge controller and a meter connected right now. This is an amp meter, which means I have this meter in line with the positive lead to the battery. And we're getting 0.35 amps at what I consider to be pretty full sunlight, so 1/3 of an amp. Let's say this battery here was 100 amp hours, and it probably is. Maybe it's a little more. Now let's say it was 50% of its charge, which means it's down 50 amp hours. How long would it take to charge a battery like this? Well, if you had 1 amp of solar constantly, it would take roughly 50 hours at 1 amp to charge that battery from 50%. We only have 1/3 of an amp, so times that by 3. So 150 hours, or what is that? If we had 24 hours in a day, 5 days, something like that, 5 or 6 days, depending on how many hours of sunlight and all that stuff. You can do the math, but people say, I just want a small solar panel, just enough to run your refrigerator and an air conditioner. Yeah, that's not going to happen. Refrigerator, okay. Air conditioner, we used to say never, but there are people that do it. But believe me, they have deep pockets and a lot of real estate to mount a lot of solar, carry a lot of batteries, probably lithium, which are not hundreds of dollars, or thousands of dollars, and a decent charge controller and all this stuff. So the one other thing I do want to add in here before we get too far along is, if you're going to wire all this stuff in permanently, we need to talk about circuit protection. Okay, we need to have some fuses going from the panels to the charge controller. We need to have fuses going from the charge controller to our load. All right, just like I showed you in my shed, I've got a automotive fuse block and fuse all the wiring that leaves the solar out to lights and 12 volt outlets and that kind of stuff. So let's talk a little bit about the charge controller. I'm not going to link any of this in the description. I bought this charge controller, let's just call it one of the cheapest charge controllers on eBay, and because of that, it was an eBay auction. The likelihood of it still being available is slim to none. So the one thing this doesn't have in it was an amp meter, and I'm disappointed in that. This was probably in the neighborhood of $12 or something. and I think it's rated for 10 amps. When you buy a charge controller, you want to buy something significantly larger than your anticipated output of your solar panels. Gives you a little room to grow, and make sure you never really push this charge controller very hard. You push them just a little bit over the limit and then they'll go out on you. So we're going to be less than 1 amp, we know that, so a 10 amp charge controller is very lightly loaded. There are some menu options in here. I'm not going to be super familiar with them all, but let's go over the wiring. Just like the other one I showed you, your solar panel connects here, positive and negative. Your battery connects here, positive and negative. And then if you have a specific load, you can connect it here, right at your charge controller. And if you do that, it'll give you a little bit of information on the display on your load. Right now we're just going from the charge controller to our battery. This is the menu button. This is a float. That means if battery was disconnected, you'd get 27.4 volts directly off the panels. Okay, the charge controller is going to take that 24.7 or whatever it was and drop it down to a charge voltage and adjust the current based on how low the battery is. Okay, let's go second one. This is going to tell you what you could get from the battery out the connection here for a 12 volt load. Third one, not sure. This is to allow you to a timer. It's 24-hour for your load, so you could connect a load here and you could tell this to run that for X amount of time. Okay, maybe like an inverter, and you only wanted the inverter to run for a short time. And then this, you tell the charge controller what kind of battery you have. However, it didn't actually tell me what those codes meant, so I was a little bit lost on that. The battery that I selected to charge is an old battery. It's not very good, and it had about 11.5 volts in it when I set this up half an hour ago. So it is charging. Still at 0.35 amps. Right now the charge voltage is 12.7. If I disconnected the charge controller, we could read the voltage on the battery, what it really is. So that's roughly how this works. Let's recap. I have two completely different solar panels. I bought this one 15 years ago, never used it. That one I picked up at a yard sale, Harbor Freight. It's very inefficient. They're both actually rated for the same output at 5 watts. I believe this one's rated at 18 volts. That one's rated at 22. We tied them together. We run them into an inexpensive charge controller. Again, this is like $12 or so on eBay. And one of my wires fell out. And I won't put a link in the description. It's got a couple USB charge ports in it, which is good. And right now we're just simply charging an old battery for demonstration purposes. And we're charging it about 1/3 of an amp. Okay. If we're trying to pick up, say, 30 amp hours of a 100 amp hour battery, it's going to take that many hours to charge, about 100 hours. So if you could charge 12 hours a day or 10 hours a day, that'd be 10 days it would take to charge that battery, those itty bitty panels. Okay, so that is the basics of a little solar system. Still very useful, depending on what you want to do with it. So if you're thinking of installing something in your cabin, your she shed, your garden shed, on an RV or whatever, do the math. Make sure it makes sense to you. If you're like me, where you keep your rigs inside under cover, well, solar's not going to do you any good at all, is it? If you find yourself, you're going to RV parks and so forth where you're plugging in, why waste the money on a solar system and take up all that room on your roof, carry all that weight of batteries, and then every so many years your batteries get old and tired and need to be replaced, and they're only getting more and more expensive every time you do that. maybe a small portable generator is more in your future than a bunch of money spent on solar stuff. So again, about $1 a watt is what you should be spending on solar panels. There are much better panels out there that you'd spend more money on, but if you've done that research, you already know that. You know, a battery like this is going to be around 150 bucks, but sky's the limit. You can go to lithiums and spend thousands of dollars. Okay, charge controller, that's in the $12 range. You can spend a lot more money on charge controllers. I showed you the cheap inverter that I picked up at a yard sale in my solar shed, but you can also spend hundreds or thousands of dollars on inverters to make 120 volt out of your 12 volt system. If you've got to the point where you're going to make a big system, then you're probably going to step up to a 24 volt system. It reduces your current by half. The costs will go up, but if you're going to build a big system, it will be worth it. And then don't forget about all your fuse protection for all your circuits, meters and remotes and all this jazz, and interfaces to a automatic start generator, and there's all kinds of options, but just understand where you're going before you get started. And with that, we'll end this video. Appreciate y'all for coming and watching. Appreciate the comments. If you haven't already subscribed to the channel, please do so, and we'll catch you on the next video. Please do a thumbs up on your way out, would you please? Thank you.